DynamicTPMS Solutions welcomes you to our TPMS training series. This is Module 2 of the series, TPMS Systems and Sensors. In this module, we'll cover direct and indirect tire pressure monitoring systems. Then we'll go over the basic components of a TPMS sensor and how it is matched to the vehicle. In Module 1, we looked at the tire pressure monitoring system concept and how it works. Now let's take a closer look at the overall system. There are two types of systems available on TPMS-equipped vehicles: a direct TPM system and an indirect. It's important to understand the difference. A direct TPM system uses sensors mounted in each tire which wirelessly transmit the tire pressure to the TPMS control module. The control module analyzes the pressure reading and turns on the dashboard malfunction indicator light if the pressure is 25% below the OE recommended placard pressure. An indirect TPM system relies on the wheel speed sensors that are part of the anti-lock braking system. These sensors measure the rate of revolution of each wheel, and using the vehicle's onboard computer, the rates are compared to each other. When one tire starts spinning faster than expected, the computer calculates that this tire is underinflated and turns on the dash warning light. With the indirect system, the actual tire pressure is not measured. The vast majority of vehicles have the direct type system that use pressure measuring sensors mounted in each tire. The direct TPMS will be the focus of our training series. Let's take a look at the basic components of a TPMS sensor. Although there are many different sizes, colors, and shapes of TPMS sensors, they share the same four basic components: a plastic housing or casing, a circuit board or chip, a small 3-volt lithium-ion battery, and a tire valve. The battery and circuit board are encased in the molded plastic housing and permanently sealed with a potting material. This secures the electronic components and protects them from the harsh environment inside the tire. This also means the battery cannot be replaced. As a result, the entire sensor assembly must be replaced when the battery life expires. Depending on driving conditions, the battery can last anywhere from 7 to 10 years. TPMS sensors must be matched to the vehicle to prevent miscommunication with any other vehicles. So how is this done? Components on the circuit board measure the tire air pressure and temperature, then wirelessly transmit that information to the vehicle's TPMS control module. The circuit board is also programmed with a unique communication protocol or code that identifies that sensor to match a specific make, model, and year of vehicle. Each TPMS sensor also has a unique ID number. This ID number is registered to the vehicle's control module along with its position on the vehicle. If any sensor is replaced or moved to another wheel position when rotating the tires, then the ID number must be re-registered to the control module along with the new position on the vehicle. This process is called a relearn procedure and will be explained in a later module. TPMS sensors transmit the tire pressure information wirelessly using a low RF signal using either the 315 MHz or 433 MHz frequency. Let's review Module 2. There are two main types of TPMS systems: direct, which uses individual sensors, and indirect, which uses the anti-lock braking system to determine a low air pressure condition. There are four basic sensor components. TPMS sensors have specific ID numbers and are programmed to match a specific vehicle. TPMS sensors transmit via an RF signal. Thank you for watching Module 2 of DynamicTPMS Solutions training series.